Hi class, I hope everyone is taking necessary safety precautions out there and staying safe. I did have an opening question before we went over graphing exponentials of I don't know if you have heard of the difference between the bird flu and the swine flu. With the bird flu, the bird flu requires treatment, and the swine flu requires ointment. So I didn't know. I just wanted to throw that out there in case you guys did contract one of those two things. So enough of the jokes. We'll go right into graphing exponential functions. Let's look at number one. Number one, we're filling in the values for x, for the exponent. So this -2 here, we're going to plug it into this exponent. So we exponent 2 to the -2. If you did that on your calculator, you would get 1/4, or you could just do it in your head. And oops. And then you substitute -1 for x, so 2 to the -1 would be 1/2. And then you'd substitute 0 for x, so 2 to the exponent 0 is 1. Now, anything to the exponent 0 is always going to be 1. Remember that. Two to the first is 2. And then 2 squared is 4. Now notice the relationship here between 2 and -2. Between 2 and -2, the y's are reciprocals of each other, 4 and 1/4. Between 1 and -1, 2 and 1/2 are reciprocals of each other. Notice that all the y values here are positive. So when drawing the x and y axis, I don't need a lot of space down here because all the y values are positive. Let's graph the point -2, 1/4. So 1/4 is going to be pretty close to the x-axis. And then -1, 1/2 is going to be between the x-axis and 1. So it's going to be about right here. Again, excuse my points. I'm still working on getting another stylus. And then 0, 1 1, 2. The way that I scaled it was that for every 1 I skipped two squares, and then 2, 4. Right, so if we connected those 4 points, look like this. So notice from left to right, this yellow line is going up. From left to right, it's growing. So this is going to be an exponential growth function. Another way you can tell is starting at -2. Look at the y values. The y values go from 1/4 to 1/2 to 1 to 2 to 4. Right? So these y values from negative to positive are growing. They're getting larger. And how much are they growing by? They're growing by a multiple of 2. Let's do 2 here. Number 2 is similar to number 1. We're going to take each one of these values of x and we're going to substitute it into that x there. So 1/2 to the exponent -2 is 4. (1/2 to the exponent -1 is 2. 1/2 to the exponent 0. Remember, anything to the exponent 0 is 1. 1/2 to the exponent 1 is 1/2, and 1/2 to the exponent 2 is 1/4. Let's plot these points. -2, 4. So -2, 4 is here. -1, 2, 0, 1, 1, 1/2, and 2, 1/4. 1/4 is, if you do 1 divided by 4 in your calculator, it'll give you 0.25. So it's going to be just a little bit above this x-axis. And we'll connect those dots. Now if you look at this yellow graph from left to right, it's going down. Since it's going down from left to right, this curve, this exponential function, is called exponential decay. So we'll circle decay. Also, you can tell these numbers here from negative to positive, 4 to 1, 1/2, 1/4, they are going down. Also take a look at the decay factor. It's 1/2. Notice the difference between the growth factor and the decay factor. The decay factor here, 1/2, is less than 1. The growth factor, number 1, was 2, which is greater than 1. For number 6, when you type this into your calculator, if you did use a calculator, get in a good habit of putting parentheses around the base of the base below this exponent x. So the values we get here are 32, 8, 2, 1/2, and 1/8. Notice again all of these are positive. So we can start down here since we don't have any negative y values. Also, I scaled it by 4, so it went 4, 8, 12, 16, 20, 24, 28, 32. I scaled it by 4s because the largest y value is 32. So I wanted this value here to be on the graph. So if we plot these points, get negative 232, negative 1802, 1/1/2, and 2/1/8. So it's getting closer and closer to the x-axis. It's approaching the x-axis, but it's not going to touch it. And then we'll connect those green dots the best we can and put arrows on the end. So look from left to right, the yellow curve is going down, and also from negative to positive we start at 32, and then as we get to positive our y values go down. So this is going to be an example of exponential decay, which makes sense because look at the base of 1/4. It's going to be a number less than 1. The base below the exponent is 1/4, which is less than 1. Alright, for number 8, they do not give you a table, so we can create a table. And I made it a little bit too big. So we're going to plot 5 points, just like we did in the previous examples. We have x and a y. Let's try the same x's that we've done thus far. -2, -1, 0, 1, 2. If you look at the graph that's given to us, the highest y value is 18. So the highest y value in our table we want to be 18 as well. If you substitute -2 into this exponent, you get 3 times 2 to the -2 minus 1, which will give you -1/4. Again, if you guys just go to Google and type in the 2 words graphing calculator, you'll find you can either click on Desmos or GeoGebra, and both of those websites will give you a graphing calculator if you don't have one yourself. We do the same thing for the next one. We're going to substitute, let's make this a different color. -1 in for x, so 3 times 2 to the -1 minus 1 is going to be 1/2. And you keep doing that. If you look at the y value of 11, 11 is this greatest y value 11, it is less than 18, so it's okay to use these x values of -2, -1, 0, 1, and 2. Ideally we want some negatives and some positives if possible. So if we plot those points, -2, 1/4, looks like the scale is 1. They go up by 1 unit each time. So -2, 1/4 is going to be somewhere down here. -1, 1/2 is going to be up here. 0, 2, 1, 5, and 2, 11. connect these points. Oh. Looks like it's going to be an exponential growth, which we could tell is going to be an exponential growth because the y values increase here from left to right. The yellow curve goes up, and then the base below the exponent is a number bigger than 1. It's 2. For number 12, if we used the x values that we've been using thus far in our examples in this video of -2, -1, 0, 1, and 2, notice the y values at the end of 129 and 1025. Now, if we used these values, our highest y value of this given graph to us is 20. So 129 and 1025 are going to be off that graph. So let's not use these values. If we instead chose the ones right above it, so -3, if you plug that in your calculator, you'd get 1.03. And if you plug in -4, that would give us 1.00391. Notice that all the y values are approaching 1, but they will never quite get to 1 or below 1. So if we graph this, 0, 17 is about right here. -3. Sorry, -1, 3. -2, 5/4. 5/4 is 1.25. So that's not exact, but it's tough with this pen. And then -3, 1.03, so it's getting closer and closer to 1. And then -4, 1.003. So we do our best to connect these points, and then it's a steep incline up. It's not supposed to be that wavy, but we do our best. So again, this is growing very rapidly. Right? Look at this growth from -1 to -1.3 to 0, 17, right? And then it grows again from 17 to 129. That's a large growth. Again, we know it's growth because from left to right, the yellow curve goes up, the y values increase, and also the base below the exponent of x plus 2 is 8, right, which is bigger than 1, way bigger than 1. If you're just curious on how to do some of these problems by hand, instead of using a calculator, let's take 0 for x. Right. So now we'd have 1/4 times 8, and 0 plus 2 is just 2, plus 1. So the order of operations say that we always do the exponent first. So 8 squared is 8 times 8, which is 64. 64 times 1/4 plus 1. Right. So 64 times 1/4 is next. It's the same thing as 64 divided by 4, which is 16. And 16 plus 1 is 17, which is 17. So that's just an example of how you could do it by hand.